Okay, so this is about finding the quadratic, and I want to go through that with you. So there's a variety of ways of doing it. I want to claim that using machines is probably an increasingly good idea for something that people find to be tedious. Now, I didn't find the differences to be tedious, like the difference between 1 and 6 um, is 5, between 6 and 13 is 7, between 13 and 22 is 9, and between 22 and 33 is 11. And then that dot, dot, dot means there's a pattern to it. So then the next successive difference between 5 and 7 will be 2, 7 and 9 will be 2, and 9 and 11 will be 2. So that's the point I start to believe that it's a quadratic in form. And over here, I'm going to tell you what the quadratic is. It looks like, I realize you're using n, but I'm using x. Ax squared, I don't know what a is, plus bx plus c, where a, b, and c are the coefficients that need to be determined. Now, granted, you can do it by hand, and the coefficients will turn out to be 1, 4, and 1. I want to use Sage to do it, though. So let me go to Sage, and I'll talk to you the code. First thing is to reset. I think you should do that every single time when you're running it. And then a, b, and c are the variables that I'm looking for. These are the coefficients of the quadratic equation. The next thing is to define a function that's quadratic. So I just put down f of x equals ax squared plus bx plus c. And my goal is to determine what the values of a, b, and c are. So then what you have to do then is you have to solve a system of equations. And this is typically done in pre-calculus using a matrix. So, what I'm doing is I'm saying f of 0 would be 1. When I say 0, because the first term is the 0th term. The second term would be f of 1 would be 6, and then f of 2 would be 13. So I typed that in, and I didn't, do much else than use Sage code to do that. And, solve. And let me repeat what we're doing. So f of 0, that's the first coefficient, so 1. F of 1, that's the second coefficient, 6. And f of 2 is your third coefficient, is 13. And I want to solve for a, b, and c. And what do you get? You get a is 1, b is 4, and c is 1. And that's what we got up here. Again, it's 1 because you get, the 1 is on the quadratic, so it's n squared, 4n plus 1. And that's what we're getting. Thank you.